We've looked at solutions and types of chemical reactions that occur in solution. We've learned to calculate concentration or molarity of solutions. The next step is to be able to use the process of titration, which is a process that's used to determine an unknown concentration of a solution by using quantitative chemical analysis. In titrometry, a known concentration and volume of solution, or standard solution, is reacted with a solution of unknown concentration in order to determine the molarity of that unknown solution, or analyte. We know that reacting a strong acid with a strong base produces a salt and water. And in this instance, we have hydrochloric acid and sodium hydroxide, which will form sodium chloride and water. If we know the molarity of the sodium hydroxide, we can use titration to determine the molarity of the acid. Typically, we would place a very precise volume of the acid along with an indicator into an Erlenmeyer flask. And the indicator that we would use for this type of reaction is phenolphthalein. Place that under a calibrated burette containing our base. And we would add the base slowly until we reach the end point where we observe the pale pink color forming throughout the solution, and you're stirring that as you're going. Then we can use stoichiometry to determine the molarity of the acid. So let's say we started with 15 milliliters of the hydrochloric acid in the flask. Well, I'm dealing with molarity here, and I'm going to need to be working with liters instead of milliliters. So as I'm doing my housekeeping here, I'm going to go ahead and change that to 0.015 liters. And we want to determine the molarity of the acid. So we'll just put X molar there. Now let's say that the base that we started with, our standard solution, is 0.1 molar. And as we went through the process of titrating, it took us 23 milliliters, or 0.023 liters of that base for us to reach our endpoint. So we'll just take that information to calculate the molarity of the hydrochloric acid. Remember the triangle? We know the molarity of the base, and we know the volume of the base, and molarity times volume will give us moles of base. So I multiplied my molarity by my volume, and I got 0.0023 moles of sodium hydroxide. Now the next step in stoichiometry after you've converted to moles is to do a mole-to-mole ratio. And in my balanced equation here, it's actually a 1-to-1 ratio. So if I have 0.0023 moles of sodium hydroxide, it'll require that same amount, since it's a 1-to-1 ratio, of hydrochloric acid to reach the end point. So now I know the number of moles of hydrochloric acid, or HCl, and I also know the volume of the acid, and so if we divide the moles by the volume, we get the molarity of the acid.